Hi again. So this will be a video about phase diagrams. So what I have up here is the nickel titanium phase diagram, and I'm just going to talk through how I think about these and some tricks for what to look for. So the first thing I want to say, there's all those definitions for your eutectic, peritectic, eutectoid, etc. But I personally don't really think of them like it's hard to remember the definitions because if you read through them, there's just so many words. So what I've been trying to instill in people that go to office hours is that I think of them this way. I think of eutectic as like bunny ears up and peritectic as bunny ears down. It's a little bit more complicated than that, but also not really. And I'll show you what I mean on this phase diagram. So, for example, if I'm looking for all the eutectic eutectoid points, I would look for this point right here. So like for example, this is a eutectic point, this is a eutectic point, this is eutectic, eutectic. So there's a lot of eutectic points going on in here, right? There's a lot happening. And so just by looking at the shape, you can get a lot of the features out. And of course there's the full definition, which is like this is a liquid and this is, I don't know, an alpha phase or something like that. Or that would be a phase mixture, I suppose. So liquid, you have another phase, we'll call this alpha and beta, etc. So you have like some line and it connects like this and beta. And then down here you have, alpha plus beta. Like there's all of that, right? But at the end of the day, what I look for, what really matters, is the shape. Like that's how you identify these things. So, and then for peritectic slash peritectoid, here's one. It's a lot harder to see, but it's right down in here. And I think that's the only one on this diagram. And so if what makes it, of course, from this point, it's eutectic if it's a liquid on the top, and eutectoid if it's a solid on the top. Ugh, I can't spell. Solid. And then the same thing for peritectic and peritectoid. And peritectoid. Okay. So, and then for also the way to think about these things is we're starting at a high temperature. So in this case, maybe you grab pellets of nickel and titanium and you weigh them out and you heat them up until they're liquid and then you're going down because that's what we're talking about is solid mechanics. We're always looking at solidification. Okay, what's next? Right. So the other thing I wanted to point out about these that I don't think was necessarily super clear on the homework is what it means for to have different compounds and to have solubility in those compounds. So for example, right here on this, I lost my thing, on this phase diagram, we have this compound tied nickel 3, and it's a straight line, right? And in between each compound, we have an interphase region. So we have this compound nickel 3, and then this one just Ti-Ni. And in between them, we have a combination, Ti-Ni plus Ti-Ni 3, right? And so one question you might ask yourself now, and I'll give you a second to try to ask this, is which of these compounds has solubility for nickel in it, right? And so, for example, Ti-Ni, you can see it's actually a region. So you can start maybe here, and you could add more nickel. In theory, you could have had this, and it would still be pure Ti-Ni. But over here, this Ti-Ni 3 has no solubility, so it's just a straight line. We could imagine it, instead of being a straight line, as being something like this one over here, this Ti2Ni. You can see it's just a really, really thin region. So it's got just a small amount of solubility to it. And you could imagine that this could also be a really, really thin line like that. Like maybe it could dissolve infinitesimally more of one or the other. So be careful about that. And then when you're reading the diagrams, you basically always check, for example, if I'm over in this region, I want it to be a pure phase, then a phase mixture, and then a pure phase. So this mixture would be beta plus liquid. Or down here, this mixture would be beta plus Ti 2Ni. And then this one is alpha plus Ti 2Ni. So you can always double check. And so I saw that on a lot of you on the homework. And I'm going to post another video where I do that final homework problem, just drawing that phase diagram, and hopefully that'll be helpful. So my last thing for you, I have these pictures up. I did this for the review for the final last year. Now that I've taken those away, I've drawn two little pictures here where I have this one, I have dragon phase, cowboy phase, and eye rolly phase. And this one I have moon phase, horn phase, and side eye phase. And so ask yourself which one of these is eutectic and which one is peritectic. And I'll leave that up to you to answer. Just scroll back up in the video if you don't know it. And then also what would make it eutectoid and what would make it peritectoid.